Hello, in this lesson we are going to learn linear graphs, and it's a continuation of our YF revision for SS3, those that are preparing for YF. So as usual, I'm using the New General Mathematics SS3, the revision part of that textbook. So the first set of questions here is on simultaneous equations. And the question says, solve the following pairs of simultaneous equations graphically. How can we solve simultaneous equations graphically? And to do that, my approach is to find the x and the y intercept, because I need just 2 points to be able to represent these equations on a graph. So for the first one, that is question A, I have x plus 2y equal to 10. Here, to find the x-intercept, I will set y to be 0 and find the value of x. Then to find y-intercept, I will set x to be 0 and find the value of y also. So let's do that. To find x-intercept, we put y to be 0. If I put this y here to be 0, the rule of this term will be 0, so that x will be 10. Hence, x-intercept or x-coordinate is 10 and 0. 10 for x, 0 for y. To find y-intercept on the other hand, we put x to be 0. We put x to be 0, that means this term is 0, then 2y is equal to 10, which implies y is equal to 10 divided by 2, which is 5. Hence, y-intercept is 0 and 5. So with these 2 points, this point here and this point, you can plot the graph of the simultaneous equation. So here is our graph sheet with the point marked on it. So the next thing now is to plot the point we have. X-intercept is 10 and 0. Here is 10, so I'll mark 10 right there. Y-intercept is 5 and 0. 0 and 5 is here. So these 2 points is what I need to plot the graph. So with my ruler, please, on those 2 points, I will join them together. That is the first graph, which is, what was the equation? X plus 2y equal to 10. We'll label it on it. X plus 2y equal to 10. X plus 2y equal to 10, that is the graph. Now the second equation, we have the equation x minus y equal to 4. X minus y equal to 4. To find x-intercept, we put y to be 0. So that if I put y to be 0, it means s is equal to 4. Hence, x-intercept is 4 and 0. To find y-intercept, we set x to be 0, so that if I set x to be 0 here, it will be negative. Y is equal to 4, dividing both sides by -1, so that y is equal to -4. Hence, y-intercept is 0 and 4, -4 rather. So locating those points, 0 and -4 for y-intercept, this is -4 right here. We change the color of this. This is -4. Then let's locate x-intercept. X-intercept is 4 and 0. This is 4 right here. So these 2 points, you can plot this graph. Okay, this is the second graph, which is x minus y equal to 4. Okay, with these two graphs plotted on the graph sheet, where the two lines intersect is a solution of this simultaneous equation. So this point of intersection here, which I trace it down to x-axis, that is about 5.8 or so, or 5.9, is on this graph. Though the graph is not perfect enough, so this s equal to 5.9, then tracing it to y-axis, y is equal to 2. That is how to solve a question like this on the graph sheet. So for B part, we have x minus y equal to 2, and y equal to rather minus x plus 6. Let's plot the first one first. To find s-intercept, we put y to be 0. If I put y to be 0 here, that means s is equal to 2. So that s-intercept is 2 and 0. To find y-intercept, we put s to be 0, so that negative y is equal to 2, meaning y is equal to negative 2. Therefore, y-intercept is 0 and negative 2. Let's plot those points now on the graph sheet. We have 1, 2, 3, 4, 5. This is 1, 2, 3, 4, 5, and negative 1, negative 2, negative 3. Let me extend this line down. Okay, for the x coordinate, we have 2 and 0. This is 2 here. That's for the first equation. And for the y coordinate, we have negative 2 and 0. Here is negative 2. So with these 2 points, we join them, which gives us the first equation. This is for the equation x minus y equal to 2. Now let's look at y equal to negative x plus 6. Y equal to negative x plus 6. To find y-intercept, we put s to be 0, so that y equal to 6. Well, this is 0, y equal to 6, so that y-intercept is 0 and 6. Now to find s-intercept, we put y to be 0. If y is equal to 0, that means 0 is equal to negative s plus 6. If I take s to this place, it becomes positive, so that s equal to 6 also. If S is 6, it means S-intercept is 6 and 0. This is 6 here. 6 for X, also 6 for Y. Y6 is here. These 2 points, let's join them together to form the second equation. Okay, this is the second graph. So the point of intersection of the two graphs, which is here, gives the solution of this equation. So X is equal to 4. Y is equal to, we trace it to, that is 2.1. Although it's supposed to be 2 because this graph is not perfect. That is why this line, looking at it here, it's not exactly on 6. This one 2. So this line is supposed to come down a little so that they intersect somewhere here, meaning Y is equal to 2. Example 2, this one is on inequality. You say represent the inequality -3 less than S less than or equal to 5 on a number line. So I will draw a number line. Let's assume this is 0, 1, 2, 3, 4, 5, 6. The line continues -1, -2, -3, -4, -5, -6. It also continues. So we are to represent -3 is less than X. So I'm going to start at -3. Since this is less than a strict inequality, we are not going to paint this. But this one that is less than or equal to 5, we will paint a circle on 5. Because 5 is inclusive, they'll connect these 2 points together and then write S on it. This is a number line showing this inequality, -3 is less than X and X is less than or equal to 5. And example 3, it says show on a graph the region which contains the solution of the simultaneous inequalities. How do we attempt a question like this? I have Y is less than 2X plus 3, and the other one is S plus Y is greater or equal to 4. Now to solve a question like this, we're going to ignore the inequality sign for the meantime and treat this as if they are equations. So if I treat this as an equation, I'll write this as Y equal to 2X plus 3. Y, this one will be S plus Y equal to 4. Like we did above, to find or to plot this on a graph, I'm going to find the X and the Y intercept. So for the first equation, to find S-intercept, I will put Y to be 0. So if I put Y to be 0, that means 0 is equal to 2S plus 3, which implies -2S and -3. I'm moving 3 here rather. -3 is equal to 2x. Divide both sides by 2, meaning x is equal to -3/2, which is -1.5 or 1.5. And to find y-intercept, we put s to be 0. If I put x to be 0 in this equation, that means y will be 3, because the whole of this term will be 0. So that, okay, here let's write the s-intercept first. S-intercept is negative 1.5 and 0. Here y-intercept will be 0 and 3. Okay, now the second line. The second line we have x plus y equal to 4. To find s-intercept, we put y to be 0. If I put y to be 0 here, it means s will be 4. So that x-intercept will be 4 and 0. Now to find y-intercept, we put s to be 0, so that y will be 4 also. Then y-intercept, therefore, will be 0 and 4. So with all these points, we can plot the graph of this inequality. However, we are treating them like equations to find their intercept. So let's draw the graph now. X and y axis. This is my y axis. This is my x axis. For the first line, the x-intercept is negative 1.5. So this is 0, the origin. This is 1. This is 2. This is 3. This is 4, 5, and 6. Negative 1, negative 2, negative 3, negative 4. 1, 2, 3, and 4. Negative 1, negative 2, negative 3, negative 4. The first one we have negative 1.5 as the point. This is 1.5, negative 1.5. As the x coordinate, the y coordinate there is 3. This is 3 here. I'm going to join these two lines together. Okay, to join these 2 points together, remember that the first line, which is the first inequality rather, is x is, the first inequality is y less than 2x plus 3. So because it's the strict inequality, which is less than, this is going to be a broken line. So we use broken line to join these 2 points together. Broken line. It's not perfect enough, but you get the idea. And so on and so forth. That is the first inequality. Now, the next thing is to locate the point that satisfies this inequality, which is y less than 2x plus 3. 2x plus 3. So how do we know where to shade in this? Are we going to shade here or are we going to shade here? I'm going to take any 2 points on the line and then test it to know which point satisfy this inequality. So I will take this point, which is 3, and this point 1 is also on the graph, so that s equal to 1, y equal to 3 into the inequality and test it. So if s is 1 and y is 3, putting it here, that is 3 Let's see whether it's less than 2 times 1 plus 3. Of course, 3 is less than 2 times 1 is 2 plus this is 5. 3 is less than 5. Meaning this side satisfies the inequality. The region that does not satisfy the inequality will be this side. So we shade all of this side. Shade all of this. Okay. That is that for the first inequality. The second inequality, what are the intercept? The x-intercept is 4. The y-intercept is also 4. So 4, 4. This is 4 right here. And this is 4 right here. So we're going to use a ruler to join these 2 points together. However, this one is going to be a bold line since the inequality is x plus y is greater than or equal to 4. It's a weak inequality. It's not strict inequality. So joining this with a bold line, this is the inequality for this second, this is a line rather, a graph for the second inequality. X plus y is greater than or equal to 4. Let me write it on it. X plus y is greater or equal to 4. Okay, with this now, we can locate 2 points and test which region satisfy this inequality. We use x equal to 4 and y equal to 5. That is this point and this point right here, which meet somewhere. So if I use this point, I'm putting it to this inequality, which is x plus y greater than or equal to 4. In this case, x is 4 and y is 5, greater or equal to 4. 4 plus 5 is 9. Of course, 9 is greater or equal to 4. Meaning this side like this satisfy the inequality. So the side that does not satisfy the inequality is this side. Shade it. So the region that satisfies this inequality is this side here.